She had exactly 17 seconds to neutralize the improvised explosive device that was about to detonate beneath the children's hospital, and every combat engineer in the 82nd Airborne knew the quiet girl from rural Wisconsin would never disarm the sophisticated booby trap in time. Staff Sergeant Jessica Chen crouched in the rubble-strewn basement of the pediatric ward in Mosul, her hands steady despite the screams of evacuating nurses and patients echoing from above. Her team had been forced to retreat when secondary explosives collapsed the main stairwell, leaving her alone to prevent what intelligence analysts called the most devastating terrorist attack on civilian infrastructure in the Iraq War. Jessica Chen had never looked like a combat engineer. At 28, she stood 5 feet 4 inches with delicate features and quiet brown eyes that seemed more suited to a preschool teacher than a soldier trained to build and destroy military fortifications. Her path to the Army's elite sapper school had been unconventional, starting with a civil engineering degree from the University of Wisconsin and a childhood spent helping her immigrant parents renovate houses in Milwaukee's working-class neighborhoods. The Fort Leonard Wood Sapper Training Facility buzzed with testosterone and doubt the day Jessica arrived for the military's most physically and mentally demanding engineering program. Master Sergeant Rick Bulldozer Murphy, a veteran of 2 Iraq deployments with biceps like steel cables, looked her up and down with obvious skepticism. "They're sending us architects now," he announced to the assembled candidates, his voice booming across the Missouri training grounds. "Hope she knows the difference between building codes and battlefield reality." The other candidates represented the elite of military engineering. There was Staff Sergeant Mike Hammer Rodriguez, a former Marine combat engineer who could construct a defensive position in record time while under simulated enemy fire. Sergeant First Class Tommy Blast Williams from the Rangers, whose demolition expertise had cleared more IED-infested roads than any engineer in his unit. And Sergeant Jake Fortress Thompson, the general's hand-picked recruit who never missed an opportunity to remind everyone that his engineering solutions had saved entire battalions during the Battle of Fallujah. "Chen, you're up," Murphy barked during the first obstacle construction exercise. The challenge involved building a defensive barrier capable of stopping small arms fire, using only materials available in a combat zone. Standard completion time was 90 minutes. Mike had finished in 68 minutes. Tommy managed 74 minutes. Jake completed his barrier in an impressive 59 minutes. Jessica approached the exercise methodically, her engineering background evident as she analyzed the available materials and calculated load-bearing requirements. She studied soil composition, measured material strength, and designed structural supports that would maximize defensive effectiveness. Her barrier took 2 hours and 37 minutes to complete. Murphy's face was red with frustration. "Chen, you just gave the enemy an extra hour to set up their attack while you played with your calculator. In combat, slow construction gets people killed." The snickers from the other candidates were loud and pointed. Mike leaned over to Tommy. Maybe she should stick to designing office buildings where nobody's shooting at her. But Jessica had built something the others hadn't considered. Her barrier incorporated engineering principles that made it not just bulletproof, but capable of deflecting explosive blasts and providing multiple firing positions for defensive operations. Her civil engineering background had taught her to think about structural integrity and multifunctional design rather than just rapid construction. "Sergeant Murphy," she said quietly, "my barrier has a blast deflection coefficient approximately 40% higher than standard field fortifications, and it provides overlapping fields of fire that would allow a small unit to defend against superior numbers." Murphy's expression showed his skepticism. "This isn't a classroom, Chen. Combat engineering is about speed and practicality, not theoretical optimization. Actually, If you examine the structural mathematics, the additional construction time results in defensive capabilities that could extend mission duration significantly while reducing casualty rates. Murphy stared at her for a long moment, then ordered explosive testing of all the barriers. When the smoke cleared, Jessica's fortification had not only survived the blast that damaged the others, but had channeled the explosive force in ways that would have protected soldiers while creating tactical advantages for counterattack. The training ground fell silent. No candidate had ever built a defensive position that actually improved under explosive testing. "Impressive engineering," Murphy admitted grudgingly, "but you still took too long to build it." Week after week, the pattern continued. Jessica would take significantly longer than the others to complete construction exercises, carefully calculating structural requirements while her classmates relied on proven field techniques and superior physical strength. Murphy grew increasingly frustrated with her methodical approach, dubbing her blueprint in front of the other trainees. The nickname stuck, and soon everyone was using it with obvious mockery intended. During rapid fortification exercises, Jessica's engineering approach was seen as a liability rather than wisdom. When scenarios required immediate defensive positions under simulated enemy fire, she would spend crucial minutes calculating optimal construction techniques while her teammates threw up functional barriers using standard military procedures. "The Army doesn't have time for architectural dissertations in every combat situation," Murphy told her after another lengthy exercise. "Either learn to build fast or find yourself designing peacetime infrastructure somewhere safe." But Jessica's civil engineering background had taught her something her classmates hadn't learned yet. Growing up helping her parents renovate old houses, where cutting corners could result in structural collapse that endangered entire families, she had learned that proper engineering prevented catastrophic failures that speed could never fix. "Fast construction only works if it doesn't fall down," her father would tell her as they worked on foundation repairs together. "Better to build it right the first time than to rebuild it 3 times quickly." 2 months into the program, everything changed during a complex urban warfare engineering exercise. The scenario involved rapidly establishing forward operating positions in a simulated Iraqi city while under constant threat from improvised explosive devices and coordinated enemy attacks. It was the kind of challenging engineering problem that combat engineers were facing daily in real urban combat zones. Mike took command of the engineering response, coordinating the 4-person team with his usual aggressive confidence. The plan was straightforward: rapid deployment of standardized defensive positions, quick clearance of suspected IED locations, and immediate establishment of secure supply routes using proven field engineering techniques. But as they began construction operations, Jessica noticed structural problems that made her deeply uncomfortable. The urban environment presented engineering challenges that standard field fortification procedures couldn't address. The buildings were unstable from previous combat damage. The soil composition was unsuitable for standard foundation techniques, and the utility infrastructure created unexpected hazards that could compromise any defensive positions. "Team leader, I'm detecting structural integrity issues that could affect our defensive positions," Jessica reported through her radio. "Copy that, Blueprint," Mike replied dismissively. "Standard engineering procedures will handle any structural problems. We build fast and adapt as necessary." Jessica studied the urban environment more carefully through her engineering analysis equipment. The building damage pattern suggested that the structural failures were systematic rather than random, indicating underlying geological or foundational problems that would affect any construction in the area. Her civil engineering training had taught her to recognize signs of progressive structural collapse that military field engineering typically didn't address. "Team leader, Request permission to conduct structural analysis before beginning major construction, Jessica transmitted. Negative, Chen. We're implementing rapid deployment protocols. No time for academic surveys. But Jessica's instincts, honed by years of working with damaged buildings, were screaming warnings. She had read every after-action report from urban combat engineering operations, studied every structural failure that had caused casualties in recent deployments. The damage patterns looked exactly like the progressive collapse scenarios that had been causing unexpected casualties for American forces in urban environments. As Mike led the team through rapid fortification procedures, Jessica made a decision that would either end her military career or save her teammates' lives. She began conducting unauthorized structural analysis of the urban environment, using engineering equipment that should have been dedicated to the team's construction mission. "Chen, what are you doing?" Murphy's voice crackled through her radio from the exercise control room. "Get back to your assigned construction sector immediately." "Sergeant, I believe the entire area is subject to progressive structural collapse. Our construction activities may trigger catastrophic building failures that could kill civilians and friendly forces," Jessica replied, her voice steady despite the career-ending nature of her insubordination. "Return to standard engineering protocols now or you're out of the program," Murphy commanded. But Jessica's analysis had revealed something terrifying. The urban area wasn't just damaged by combat. It was systematically undermined by an enemy engineering operation designed to cause mass casualties when American forces attempted to establish defensive positions. Every standard construction technique would trigger carefully placed explosives that would bring down entire city blocks. "Team leader, do not begin foundation excavation," Jessica transmitted urgently. "The enemy has undermined the entire area with a coordinated demolition plan. Any significant construction activity will trigger massive structural collapse." Mike's voice came through the radio, confusion replacing his earlier confidence. "What are you talking about, Chen? We're following standard urban fortification procedures." "The damage patterns aren't from random combat," Jessica replied, her analysis screen showing the true scope of the enemy engineering operation. "This is a coordinated demolition plan designed to kill American engineers. Every foundation we dig, every load-bearing modification we make, is designed to trigger catastrophic collapse of multiple buildings simultaneously." Jessica had identified the enemy's true strategy. The urban area had been turned into a massive booby trap that would cause devastating casualties when American forces tried to establish defensive positions. The apparent structural damage was actually carefully engineered to create cascade failures that would kill hundreds of people when triggered by standard military construction procedures. "The entire neighborhood is one giant IED," she announced to the team. "We're not just building in damaged buildings, we're building in a carefully designed death trap." Working frantically, Jessica began developing construction techniques that would establish defensive positions without triggering the enemy demolition system. It required understanding not just military engineering, but the complex interactions between structural damage, geological stability, and explosive placement that the enemy engineers had used to create their trap. "How did you identify the demolition plan?" Murphy asked through her radio, his tone shifting from anger to professional alarm. "The structural damage follows engineering patterns, not combat patterns," Jessica explained while continuing her analysis. "The building failures are too systematic and too coordinated to be accidental. Someone with advanced engineering knowledge designed this area to collapse in a specific sequence when disturbed by standard military construction." Over the next 2 hours, Jessica's approach proved correct. Her alternative construction methods successfully established defensive positions without triggering the enemy demolition system, while her structural analysis revealed the locations of primary explosive charges that could be safely neutralized by explosive ordnance disposal teams. When the exercise concluded, Jessica had not only prevented catastrophic casualties, but had turned the enemy engineering trap into a tactical advantage by understanding its design well enough to avoid its triggers while using its concealed positions for American defensive purposes. The debriefing room was silent as the exercise controllers reviewed the analysis. Jessica's identification of the coordinated demolition plan had prevented what would have been the largest single casualty event in the exercise's history. Murphy stood at the front of the room, his expression a mixture of amazement and respect. "Chen, your engineering analysis was brilliant. You identified a threat scenario that our doctrine doesn't even address." Jessica remained quiet, knowing that praise for unauthorized actions could quickly turn to disciplinary problems if her insubordination was seen as insubordination rather than initiative. "However," Murphy continued, "your ability to think beyond standard procedures while developing innovative engineering solutions shows exactly the kind of strategic thinking we need in modern urban combat engineering." Mike stepped forward, his earlier arrogance replaced by genuine admiration. "Sergeant, Chen saved all of us. Her analysis was perfect, and her construction methods were more sophisticated than anything in our current field manuals." The other candidates nodded in agreement. Even Tommy, who had initially dismissed her as too slow and academic, now recognized that her methodical approach had consistently produced superior results under the most challenging conditions. Modern combat engineering requires understanding enemy capabilities as much as our own construction techniques, Jessica explained when asked to brief the class on her methods. Speed and technical skill are still important, but the ability to recognize when standard procedures have been compromised is becoming critical in complex threat environments. Over the following weeks, Jessica's analytical methods began to influence the entire program. Her approach to threat assessment, combined with her innovative construction techniques, started appearing in other candidates' engineering planning. Murphy began incorporating her methods into the official curriculum. The final exercise was a realistic scenario based on actual urban combat engineering operations. Jessica's team was tasked with establishing a forward operating base in a heavily damaged urban environment while defending against sophisticated enemy engineering countermeasures. It was the kind of complex operation that combat engineers were conducting regularly in real urban warfare situations. Jessica was assigned as the structural specialist, a role that typically involved supporting the team leader's construction decisions without question. But as they analyzed the urban environment, Jessica's assessment revealed complications that standard engineering doctrine couldn't address. The enemy had used advanced engineering techniques to create structural instabilities that would be triggered not by explosive devices, but by the natural settling and stress patterns that occurred when buildings were modified for military use. It was a sophisticated approach that turned routine construction into a delayed action weapon. "We need to completely rethink our construction approach," Jessica proposed during the initial site assessment. "This isn't just a damaged urban environment. It's an engineered structural trap that uses physics rather than explosives to create casualties." Jake, who had been designated team leader, was skeptical. "Advanced engineering traps are beyond typical enemy capabilities. We stick to proven urban fortification techniques." "The structural modifications I'm seeing require university-level engineering knowledge," Jessica replied. "Someone with advanced training has turned basic physics into a weapon system that targets our construction procedures." The debate continued while precious time passed and the team remained vulnerable to enemy action. Finally, Murphy made the decision to let Jessica implement her unconventional approach to physics-based structural threats. Jessica's engineering solution was unlike anything in military doctrine. Instead of fighting the enemy's structural modifications, she designed construction techniques that used the engineered instabilities as tactical advantages, turning the enemy's physics-based traps into defensive features that protected American forces while creating vulnerabilities for attacking enemies. "I'm using their engineering against them," she explained as she worked. "If they've designed the structures to fail in specific ways, I can design our modifications to control and direct those failures to our advantage." Jessica's construction techniques were elegant in their sophistication. She created defensive positions that appeared vulnerable, but were actually designed to channel enemy attacks into kill zones, using the structural modifications that the enemy engineers had intended as traps. The physics-based weapons became physics-based defenses when properly understood and redirected. Within 4 hours, Jessica had turned the enemy's sophisticated engineering trap into the most effective forward operating base in the exercise's history, with defensive capabilities that exceeded anything achieved through conventional construction methods. "How did you turn their traps into our advantages?" Murphy asked during the final debrief. "I understood their engineering objectives," Jessica replied. "Once I figured out what structural failures they were trying to create, I could design modifications that would redirect those forces to serve our tactical needs instead of theirs." When graduation day arrived, Jessica Chen stood at the top of her sapper school class. Not because she was the fastest or most physically capable engineer, but because she had proven that structural understanding and engineering analysis were more valuable than speed and conventional construction techniques in modern urban warfare. Colonel Patricia Martinez, the commanding officer of Army Combat Engineering, presented her with the Distinguished Graduate Award. "Staff Sergeant Chen represents the evolution of military engineering," she told the assembled crowd. "She has shown us that the engineer who understands the physics of the battlefield will always outperform the engineer who relies solely on standard construction procedures." Jessica's innovations were quickly incorporated into combat engineering doctrine across all branches of the military. Her approach to structural analysis, once seen as too slow and academic, became the foundation for next-generation urban warfare engineering methodology. Years later, when asked about her success in sapper training, Jessica would always credit her parents' renovation wisdom. "They taught me that every building tells you what it wants to do," she would say. "You just have to listen carefully enough to understand the forces at work before you start changing them." The quiet girl from rural Wisconsin, who had been dismissed as too slow and theoretical, had revolutionized modern combat engineering. She had proven that in an era of sophisticated enemy engineering and complex urban environments, the greatest advantage comes not from building faster, but from understanding the structural forces that determine whether what you build will protect your people or become their tomb.